In this lesson, we are going to look at the acceleration as part of the linear motion. Now, acceleration is defined as the rate of change of velocity. Acceleration tells us how fast the speed of an object that is moving is changing. Now, here the symbol for acceleration is, we have our A, so that is the symbol for acceleration. Then the second one, the units for acceleration are meters per second squared. Now, in order to find the acceleration, the formula for acceleration is acceleration is equal to, so this is just the slope, but we just say final velocity minus initial velocity then divided by the time taken. So the time taken from the initial up to the final velocity. Then in symbols we have A, the final velocity is denoted by V, then our initial U over T. So this is the formula for acceleration. Now, so acceleration is just like dividing the velocity by time. Okay, so now let's look at how these units for acceleration came into existence. And we said acceleration is has units of meters per second squared. So let's see. So we can see that for us to find the acceleration, we need to have the velocity then divided by time. So this is can be written as velocity divided by t. Then we know the units for velocity is meters per second. Then divided by the unit for time is second. From there we can see that meters over second, if this changes to multiplication, we are going to have 1 over a, so we need to turn the fraction upside down, which is giving us m times 1 is m over s times s is x sc squared. So this is how the units, we can derive the units of acceleration. Then the other thing we can know about acceleration is a vector quantity. So we can make some notes. The definition for acceleration, we said the rate of change of velocity. Then the units for acceleration are meters per second squared. Then in terms of it is a vector quantity. Now the acceleration tells us how fast the velocity of an object is changing. Now there are also some formulas that we need to look at. So we have the second formula. We'll just consider, and these are known as the equation of motion. So the first one, we can rearrange the first formula, and we have this formula where final velocity is equal to u plus at. Then the second formula we can have is displacement. So our s denotes the displacement is equal to u plus v times t over 2. Then the third formula we have is displacement is equal to ut plus half at squared. Then the fourth one is v squared is equal to u squared plus 2as. So where our v represents final velocity, then our u initial velocity, our t time, then our s displacement, In a case where an object is moving in a straight line without making a turn, this can also denote the distance. Then from there also we can look at A. This one represents the acceleration. So these are the basics that we need to have as we are dealing with problems of acceleration. Now, there are some conditions that you need to have in mind whenever you are trying to use these formulas. The first condition, you need to make sure that the acceleration must be uniform. So we are going to use a graph to how to identify when acceleration is uniform. Then from there also the motion may be in one dimension, that is in a straight line. So now from there, if one direction is positive, the opposite must be negative. So these are the two conditions that we need to have in mind as long as we are dealing with this equation. Okay, now let's look at the first example, and this example we are going to use the velocity time graph. Okay, so now the figure below shows a velocity time graph of a car that travels between 2 points. Okay, so now this diagram here is giving us a picture of a velocity time graph. So a velocity time graph is just a graph that consists of velocity on the y-axis and time on the x-axis. Now we can start this diagram, and also we can look at, so now from point A to B we have a straight line. Then now this line is moving upward. B to C, a straight line that is parallel to the x-axis. CD, a straight line that is moving down. Now the first question is, we are trying to describe the motion during AB. So let's go at point AB. So we can see that AB is moving in a straight line like this. So now if we are to find the gradient, if we use algebra and find the gradient of this line, the gradient of this line will give us a positive value. So any line that moves upward, that slant moves upward, we have a positive gradient. And whenever we are dealing with acceleration of a line that is moving upward, that is a positive value. Then apart from that, whenever we have a line moving upward and straight, there we can now say that the acceleration is constant. So here we have the acceleration of the car was constant. So always whenever you see a straight line, the acceleration is constant. Now if the line is not straight, maybe if we have a curve, the acceleration is now not constant, it's changing or it's varying, it depends with the point. Now for BC we have a straight line like this. So whenever we have a straight line parallel to the x-axis, the gradient is always 0. So at point BC there is no acceleration, and the reason why there is no acceleration because the velocity is constant. So whenever we have a constant velocity, the acceleration is 0. Acceleration can only be there if the velocity is changing. As we said, acceleration, it is just how fast the velocity is changing. So BC, at point BC, we have a constant velocity. So the acceleration, okay, let's use, so the velocity was constant. So when the velocity is constant, we are saying no acceleration. We can just say the acceleration was 0. Then let's look at CD. So now for the CD, the line is slanting down here. If we are to find the gradient of this line, we are going to find the gradient will be negative. So therefore, our acceleration of a line that is slanting downward is always a negative. Now, the other thing that we need to know is, since it's a straight line, the acceleration which is this acceleration is known as a deceleration or retardation. So you can say the retardation was constant. So one thing that you need to have in mind is when we have a retardation or when we have acceleration that is decreasing, or a line that is moving downward, the point that we need to have in mind is the velocity is reducing. So during retardation, the speed or their velocity is decreasing. Then during the acceleration where the line is moving upward, like during point AB, here we are expecting the velocity of the car to increase. Then from there, let's look at question B. What is the maximum velocity of the car? So the maximum velocity of the car, the maximum, we are looking at the velocity at which this car reached. So the maximum velocity can be obtained between point B and C, because from the graph here we can see that this was the highest height reached by this graph. So the maximum velocity was 12 meters per second because it didn't exceed that point. Then the other question is, at which times is the car at rest? So if you want to identify when the car is at rest, we need to have their velocity must always be 0. So at the point where the velocity is 0, so at point A we can see that the velocity is 0. Even at point D we can see that the velocity is 0. So at so we can say at t is equal to 0 and t is equal to 21. So at t is equal to 0, the acceleration is at rest, and also at t is equal to 21, the acceleration is also, the car is also at rest. Now, D, calculate the distance covered from t, from 6 seconds up to 16 seconds. So we are trying to find this distance covered here. So for us to find the distance can be found by multiplying velocity times time, or we can also just say distance can be found by finding the area of BC. So the area of BC can be found by L times B. So we have the length and we also have the breadth. So let's look at how can we find the distance here. So velocity. So since we are looking at when time was 6 seconds and time was 16 seconds, so we are finding the distance between B and C. So you can see that the velocity during B and C was constant and 12. So that was 12 meters per second times Z. We need to find the seconds that were taken from B to C. So we can see that B is 6 seconds, C is 16 seconds. So we need to find the difference between the two numbers. So 16 minus 6 is 10. So the time taken was 10 seconds. So we can cancel the second. We can see that 12 times 10 is 120 meters. So we can find the distance by multiplying velocity with time. Then we can also find distance by just finding the area, like the one that I've shaded here. So we can see now one must be length, the other one must be breadth. So we can see that this line, the one in red here, this line from here up to there, that is just 12. Then from 6 to 16 is 10. So this one will be L. L is the longest length, the longest distance. Then our B or width is the shortest one. So since from 6 to 16 we have 10, that is our B. So we can see that here we have 12 times 10. We still get the same answer, which is 120 meters. Okay, now let's say also, let's try to calculate the acceleration. So we are going to find two acceleration. The first acceleration, we are going to find the acceleration in the first 6 seconds. So the formula for acceleration is equal to final minus initial over t. So let's now go from the graph. Here we are finding the acceleration between point A and B. So this acceleration. So the initial is where the line is starting, or at the starting point. So our A represents the initial, then our B represents the final velocity. So from the diagram, we can see that the final velocity at point B, from the y-axis, we are able to see that the final is 12 minus the initial is 0. Then we need to look at the time taken between B and C. We can see that here we have 6 seconds. So 12 minus 0 is 12 over 6. 6 into 12 is 2 meters per second squared. Then also we can also find the deceleration now. Let's find the deceleration in the last 5 seconds, or from C to D. So here we are going to say acceleration is equal to final minus u over t. Now from this point, our C is our initial, because that is where the line is starting. Then our D is our final. So this is how you need to take from the graph. So we have the initial. Now A is equal to the final, since the line, this line CD is touching the x-axis. When the line is touching the x-axis, the final is always 0, minus the initial C. The initial, we can go from the y-axis, the initial is 12 over 21 minus 16 is just 5. 0 minus 12 is negative 12 over 5. Then 5 into 12 is 2.4 meters per second. So this minus sign is telling that we are dealing with the retardation, or the speed of the car is reducing until it came to rest. Then also, the other question that we may encounter, you may have a question where you are told to find the total distance traveled by the car. So the total distance can be calculated by finding the total area of this shape, and we are able to see that we have the trapezium. So the trapezium has the formula half A plus B times h. Then from the shape of the trapezium has a shape like this. So this, the upper part, the smaller upper part, this upper part is the distance A. Then the lower part here, the longest one, this is our B. Then the vertical line here is our height. So from this graph, we can proceed by saying distance is equal to half our A is the distance from B to C. So we need to find the value from B to C. So B, we are going to use the ones from the x-axis. So we can see that if we move from B down here, we are reaching point where there is 6 and D. So we are going to find the difference between 16 and 6, which is 10, plus C. The B is just the distance from point A up to D, which is 21. Then multiply by the height, which is 12. So 10 plus 21 is 31. Then times 12. We can find the half of 12. Half of 12. So 2 into 12 is 6. So you can now multiply 6 times 1 is 6, 6 times 3 is 18. So the total distance traveled was 186 meters. Then we can also find the total distance by finding the distance for each shape according to the diagram. So let's find the distance between point A and B. So here the distance, we can see that here we have the shape of triangle. We have the shape of triangle, this one. So the distance is half BH. So from the triangle, the shape of the triangle, the B is the base, the H is the height. So you can see that the base is here 6, the height is 12, which is distance is equal to 2 into 6 is 3 times 12, which is the distance at that part is 36 meters. So the car traveled from point A to B, covered the distance of 36 meters. Now B to C, we calculated the distance from B to C. So let's just find the distance of CD. So CD also we have a triangle. So this is half BH. Half our B here, from here up to there, we can see that is 5. Our height is 12. Then half of 12 is 6. 6 times 3 is 30. So now after finding the distance for each part, we can now add. So the total distance will be 36 meters from B, A and B. Then from B and C was 120 meters plus 30 meters. So we can see that we still get 186 meters. So this is how you can find some questions on a velocity time graph. So that's it for this video. Thanks for watching.